Okay, we're gonna start. So thank you again, everyone, for being here with us. This Mako Solar webinar. We're gonna talk about the best PV solutions for residential projects. My name is Carlos Hernandez. I'm international sales coordinator at Mako Solar. And well, first of all, I'm gonna start with the Mako Solar introduction as a company, what we do, what we are as a company for the people that doesn't know about us. So Mako, it's a company dedicated to wholesale distribution in Latin America and the Caribbean. It's a company with almost 100 years of being founded. We were founded in 1922. We have sales for more than $100 million per year. We are more than 700 employees, and we sell to more than 30,000 B2B customers. This is very important because Mako doesn't sell to the final customer. We doesn't reach the final customer. We sell to other companies that reach that final customer. Okay. So what is Mako? Mako is these seven divisions, these seven commercial divisions, as you can see here. Each division is completely independent in its commercial work. So each commercial team is completely independent. So we have a solar, home, hardware, food service, liquor, automotive, and mass consumption division. And we share a back office of finance, logistics, administrative, all the divisions together. Okay, so this is Mako. What we do in the solar division. In the solar division, we are exclusively dedicated to distribution of solar equipment. This is very important because we only do distribution. Okay, we don't develop project. We don't do design. We don't do consulting. We sell the products and we sell the solar equipment to professionals in the solar field. So basically installers, developers, EPCs. Okay. Where we do this in all Latin America and all the Caribbean. Okay. What we have to offer as Mako Solar? Well, we have to offer, first of all, is you can find every equipment and all the equipment you need for your projects, modules, inverters, racking, BOS with us. You don't have to go and find four different providers. We can manage all your products and everything with us. Second thing, we have really, as a company of 100 years, we have a big experience in customized logistics. So we can sell in the Incoterm you need. So we can sell CIF in your country. We can sell also Xworks in a warehouse, either Miami or Panama, as I'm going to show you a bit later. Third thing and very important is the quality of the equipment we sell. So we only work with the best brands in the market, the best quality and the best technology. Okay. And finally, and it's very close related to the quality and the brands we work with is the warranty. So we only work with the best warranties, and something that is very important is the support of the company that is selling to you. So Mako, as a company of 100 years of history, you're gonna be sure that in 10, 15 years, when you're having a problem with your project, you can count on Mako. You can be sure that Mako is gonna be there to bring you all the support and whatever you need with your project. So that's very important for us. Okay, this is our location. So we have two international warehouses, one in Miami and the other one in Panama. We ship right now to 21 countries in all Latin America and the Caribbean. And we also have warehouses inside Colombia where we ship all over Colombia. Okay, so this is about Mako. So let's get into the topic of today's webinar. If you have any question, please feel free to put it in the chat box, and I'm gonna be answering all over the webinar. Okay. So what are we gonna talk about regarding the PV solutions? So we're gonna talk about modules, specifically about technology of the modules, the power and the size of the modules that you should use in your residential projects. We're going to talk about the inverters, if you should use microinverters or strict inverters, what are the important things that you need to have in mind when you're choosing the type of inverter. And finally, the racking, the bill of materials that you need, and the important things you need to think about with the racking selection, okay? So let's start by the modules. So the two most important technologies that you have to have in mind when you're choosing your equipment for a residential project is the technology of the type of the cell. In this case, monocrystalline cell. I'm going to talk about this in depth a bit later. And then also the half cut technology. These are two technologies that you have to have in your projects for residential installations. Those are the most important technologies that you have to assure in your projects. And why is that? The first one is that you have to use monocrystalline modules. And why do you have to use monocrystalline modules and not polycrystalline modules? Well, this is very important because when you're making residential projects, the space is always a problem. You're gonna have always space limitations, difficult, for example, layouts. So you're gonna have windows, you're gonna have different orientations. So you need a module that is more efficient. So you need less space, less modules, and you're gonna have, in the case of the monocrystalline modules, you're gonna have a better behavior at high temperatures. In the places where we make our projects and where we install in the Caribbean, in Central America, where the temperatures are really, really high, this is very, very important because if you have better behavior at high temperatures, this means that you're gonna have more energy productions throughout the life of the project. So even the smallest difference throughout 20, 25 years of a project can make the difference in the payback of the project. Okay, so that is very, very important and is something that you have to have in mind. The other reason is, as I told you here, is less space and less modules. Why is that important? Let's take an example, let's take as an example, this 10 kilowatt project. So for taking 10 kilowatt project, you're gonna have two options. For example, a polycrystalline 345 watt module and a monocrystalline 400 watt module. For this 10 kilowatt, you're gonna need 29 units of the 345 watt polycrystalline. With the monocrystalline, you're gonna need only 25 units. What this means? That you're gonna use less area, you're gonna have less problems with setting the layout and the areas in the roof where you're gonna install, and that means also less racking, so less costs for the project and less BOS. And not only you have to think about the materials, so yeah, it's less racking and less BOS, but that also gets and that also is very important because if you have less parts and you have less equipment to install, you're going to install faster. So for the installer, for the EPC, this is something that you have to have in mind because it's going to be cheaper, the installation time, well, all the things that regards installation. So this is very, very important. So that's why we encourage installers to use monocrystalline modules over polycrystalline modules for residential projects, okay? Maybe for bigger projects, commercial projects, but you have big areas, you don't have problems of layouts as in residential projects, you can maybe have a good production and a good payback of your project with polycrystalline modules. But in this case, you're gonna find that monocrystalline is gonna be the best solution. And I'm going to talk about this not only regarding modules, but also regarding microinverters. And this is something we're going to talk about a bit later, because if you are using microinverters, it's better to use modules with higher power. Why? Because obviously, if you put 29 modules of 345 watts, you will have to buy 29 microinverters and not 25. So that is very important because it's going to be a big difference in the cost of the project. Okay, so let's continue with the next technology that you have to have in your residential projects, and this is half-cut modules. And this is very, very important because the half-cut technology is basically you take the wafer and the cell and you cut it in half, and what you do is a reorganization of the electrical circuit inside the module. So in the full cell modules, what you have is three big circuits that are taking out the power and the energy from the module. Okay, so extracting all the power and the energy. So in this case, the energy needs to travel all this way in the module, inside the module. So it has a very big internal resistance. It has greater losses of power, and I'm gonna talk a bit later regarding the shadings. But you have big problems if you have shading on a module. With the half-cut modules, what you do is that you cut in half the module, you make this reorganization of the circuit, and then you have 6 circuits, not anymore 3. So in that case, when you have a shading, as you see here in this module, is as it is the same on the other one, here, when you have this shading, you're gonna lose 66% of the module because these 2 circuits are completely lost, okay? But in the case of the half-cut module, you're gonna lose only 33% of the production. So it makes a lot of difference when you have projects where you are gonna be having partial shadings, small shadings, and changing shadings throughout the day, okay? So this is very important to have in mind. So when we see this kind of projects where you have all type of trees, all type of different orientations, and shadings that are gonna be changing all day long, you have to think that when you're having this half cell configuration, you are gonna have, with the same power, the same type of module, you're gonna have twice the number of circuits, of electrical circuits in your modules. So what that means, that the probability of you losing power in one of these circuits is less. So that means that when you have this type of projects, when you're having trees, you're having problems, for example, with the other houses, with chimneys, with all these type of obstructions. In this case, this is the best technology that you can have. You're gonna maximize the production, and as you saw here, the losses are gonna be a lot less, a lot lower than with full cell modules. Okay, so that is very, very important, and you have to think that the project is gonna have this type of behaviors, and what you're trying to do is always giving the best percentage or probability of not losing power during the life cycle of the project. Okay, so let's go on and let's talk about something that is really, really important, and it is the power that comes also with the size of the module. Okay, so normally and usually people like to use 60 cell modules for their residential projects. So why the people choose this type of modules? They choose these modules because they are easy to install. They are easier also to fill the roof with the modules, because you have smaller dimensions, is not as longer or taller as the 72 cell modules, and you can find in some cases better layouts with this type of modules. What's the thing about and what you have to think when you are making this decision of choosing a 60 cell module or a 72 cell module is that if you choose the higher power, that is the 72 cell module, you're gonna use, first of all, less modules. Second, less racking because you're using less modules. And third, less BOS. And this is very important because you're saving in that project. So this is important, but the most important thing is to think which type of inverter are you using. If you are using, for example, microinverters, using 60 cells modules means that you have to put more microinverters into your system. So if you use, for example, 72 cell modules or 144 half cell modules between 385 and 410 watts, you're going to use less microinverters and you're going to have and get more profit from the microinverter with this type of powers. And we're going to talk about that a bit later. So if you are using microinverters, please make sure that you try to use 72 cells because you're going to use less microinverters and you're going to be having less costs in your projects, not only regarding the quantity of microinverters, but also regarding the racking and the BOS. Okay, so that is very, very, very important. So let's talk about now about inverters. So we have two examples. They are absolutely the same. So in the left side and in the right side, we have 6 modules, the same array with the same conditions. So on the left side, we have modules that are having a shading, for example, here, these have scratch, this has hotspot, this is not clean. In the right side, we have the same thing, sorry, but what you have to have in mind is when you're using a string inverter, with, in this case, the production of the string is going to be the lowest of the production of the modules that are inside the string. So if this is the lowest module in this string, this means that the whole string is going to work at 50% of the production, okay? And even if you have modules that are working at 100% or 90%, you're not going to be able to extract that energy because the MPPT of the inverter is going to set the MPP point in the worst condition of the modules, okay? So even if you could get more energy, the inverter, normally the standard inverters, string inverters, won't do that, okay? Sorry. On the right side, using microinverters with the same condition, if you use one microinverter per module, each module, it's a unique world. It's independent to the other. And what that means, that each module is going to have its own MPPT that is going to extract and take profit of all the energy that is being produced by that module. It doesn't matter what is the percentage of that module and the production of that module, because the microinverter is going to take everything that the module can give. So this means that in the same conditions, with string inverters, you're going to have a production, in this case, for example, of 50%, and with microinverters, you could have a production of 84.2%. So even if the microinverters are a bit more expensive, you're going to have greater production, greater, in this case, benefit, economic benefit. So the payback of the project is going to be faster. So you're going to have your project closing, economically closing, I don't know, in 3 years with microinverters and string inverters in 5, 6 years. Okay. So this is very, very important to have in mind. And for residential projects that you have this type of conditions, that the same images as I shown before, with shadings, with modules that are not being cared and washed, that can be and that can have scratches with different orientations. So the MPPT is not even with all the orientations. In these cases, the microinverters is the best solution because you're going to have the best production that you can get. And also the monitoring is something very important, because if something happens to a specific module, the owner of the system, the owner of the house can go and see, okay, the module that is having problem is this one. I can watch it. I can see if there is a problem visually with the module, and have by its own a fast and easy solution to that. If you have a string inverter, you never know which one is the module that is having the problem or the trouble. So in that case, you also have to think about, okay, the microinverter is going to be better for the maintenance, the O&M of the project, okay? Something very important, and this is a very common question, and it's regarding the power, the best power to fit with a microinverter. So let's do an example with an IQ7, Enphase IQ7 microinverter. This is a microinverter that has an output of 295 volt ampere, 295 watt. Okay, so usually you see that when you install and when you design projects, the recommended DC to AC ratio is from 1.15 to 1.3. Okay, if we make these numbers and we multiply these 295 watts per 1.15 and per 1.3, we have this band, this work band, that it's from 340 watts to 385 watts. And this is normally what the installers do. They say, okay, my band, so I have to choose, I have to select a module between 340 and 385 watts. But what they are not thinking is that the project is not going to be static throughout the life and throughout the 20-25 years. Okay, your modules are going to be degrading all the life of the project. So if you see in the, for example, in the data sheet of the module, you're going to see, in this case, it's a Trina module, for example, you see that it's a straight line, and you're going to go from the 100% or 97.5% to the 83% of production or power of that module in 25 years. What this means, that if, for example, we take a 340 watt module, and we see and we calculate, for example, in 10 years or in 5 years, which power is going to have, you're going to have less than 330, less than that. You're going to have about 320 watt of power with that module. So what is going to happen then with that module? That module is not getting all the power that the microinverter could be generating. Okay, so in that case, what you have to think is, okay, I have to take in consideration that when I'm making this type of selections, the project and the module is gonna degrade, and then I have to select a module that in 5 to 10 years is not gonna be having less profit of the microinverter. So maybe you are choosing a power that in the first 1-2 years is going to be too high for the microinverter. Okay, you're going to have clipping, you're going to lose power. But then when you pass the second year and you are having, for example, 5%, 6% loss of the power of the module due to this degrading, you are taking profit of the 100% of the microinverter power. Okay, so in that case, if you take these accounts, you're gonna find that the best choice for, in this case, an IQ7 Plus with 295 watts is gonna be a module between 385 watt to 410 watt. This is gonna be the best band when where you have to choose the module to be completely sure that you're gonna take advantage of the power generation of the microinverter throughout the life of the project. So remember, you're not designing only for the first 2 years of the project. You're designing for 15, 20, 25 years. Okay, so don't design only with the starting point, but design with a longer band of life that it's gonna be, for example, from 5 to 15 years of life of the project, or from 5 to 10, or from 2 to 10. I don't know. That depends on your type of project, but this is something that you have to have in mind when you are choosing the type of module. So don't choose modules, small modules, or well, no, those are not small modules, but don't choose this completely by this DC-AC ratio. Think about the degrading of the module, and having that in mind, you can find a better life and better economic payback for your project. Okay. So if you're having residential projects, I explained it before why it's better to use microinverters. But if by any reason you are not using microinverters and you are choosing string inverters, please make sure that the string inverters you are choosing have a shade fix or dynamic peak manager. And what is this? This is a software on the MPPT of the inverter that it's gonna be able to have less loss due to shading of the modules. Okay, so this is the scenario that you're gonna usually have. So trees, chimneys, orientations, different things that are gonna be shaded. What happened when you have a shading? So when you have a shading, you have here in blue the normal shape of the power curve of a module. Okay, so here in blue you have a complete and direct sun to a module. Okay, when you have a partial shading, what happens here is that you're gonna have this red line. Okay, so in the blue line, what the MPPT of the string inverter is doing is setting the best point of generation and extracting the most amount of energy from that module. Okay, but what happens when the shading is coming and you're gonna start having shading in your project? You're gonna find this red curve that if you have a normally standard inverter, what the inverter is gonna do with the MPPT is set it up in this point. So basically the curve is gonna go down, and they're gonna start looking for the MPPT always from the right side of the curve. So he goes to the right side of the curve and he finds this point. And this is a MPP, a maximum point of power, but it's only a local maximum point of power. So what this software, this shade fix or dynamic peak manager from SMA, from Fronius, from the best brands in the market of string inverters, what these do is that the MPPT software is not going to look only from the right. It's going to look all the way, all the curve. So in that way, he can find the global MPP and not only the local MPP. So in that way, you can have less losses due to shading with this type of string inverters. Okay, but you are gonna find that well, 98% of the times it's better to have microinverters. If you have shading, it's better to have microinverters than to have string inverters in your projects. Okay. Again, if you have any question, please feel free to put it in the chat, and I'm gonna be answering them right away. So let's move on with the next thing, and it's about racking. So what is important about racking in residential projects? So in residential projects, it's very important that you have easy, fast, long-lasting, and certified racking. Why this is very important? Because when you're doing residential installation, you normally install, and those are projects that you are thinking, okay, this project is gonna last 10, 15 years. And the idea is that you don't have to do any maintenance, any operation different than the standard maintenance that you do each 6 months or each year of the project. But the idea is that the installer is not gonna be doesn't have to keep going to the installation and see what it's happening, that you're not gonna be having problems, for example, with winds. So in that way, it's really important to have a good solution, okay, a certified solution, a certified brand. So in this case, for example, you are looking for products that are really easy to install, so you're gonna be installing them fast, so you're gonna be making more installation in less time, less expensive, less cost for you as installer, and of course, with the best warranty, 25 years in the case, for example, of Unirac, and the best certifications. For example, in this case, I'm gonna jump this for a moment. For example, the certification for Unirac of high wind approval for solar mount, that is the rail solutions that I'm gonna talk about a bit more. So you're gonna be completely sure that with a hurricane, you're not gonna have modules flying away and having troubles with it. So these type of certifications are very important, because you can be sure and completely sleep tight, and not having to think about this on the nights, that okay, what's gonna happen if a hurricane come to my island or to my project. Okay, no problems, I have complete certification and 25-year warranty that nothing is gonna happen with my racking. The other thing that is very important is choose the best and the not the best, but the solution that it's made for the type of roof you are working with. And why is that important? Because if you choose the right solution, you're gonna be able to install faster, okay? It's gonna be easier and it's gonna be faster. So, for example, these are the two main roofs that you can find, for example, in the Caribbean. That is the shingle tile and the Spanish tile, or the clay tile, many names to this one. So if you choose the right solution, you're gonna be able to install very, very easy. So even with the hooks, or in this case with the output and the plaque. Okay, so yeah, this is very, very important. Also have in mind that if you start to think about everything we talked, it's always like carrying things in the design. What I want to say about that, and what is that idea? So if you choose and you design your project, for example, with a polycrystalline 60 cell module of 300 watts, for example, in that case, you are taking the first decision that it's gonna impact all the project in its design. So if you choose this type of modules, for example, those 60 cell polycrystalline 300 watt, you're gonna have to use more microinverters, okay? You're gonna have to use more racking, and In that case, you're gonna have to use also more BOS. What that means that you can have a perfect project, a great project that has good economical outcome for the client, but if you think you could do that same project with better technology, with better design, and have a better outcome for you and also for your customer. So if you change small things in your design, such as choosing monocrystalline half-cut modules between powers of 385 to 400, 410, 1 meter per 2 meters, so 72 cell array. Uh, Only with this small thing, you're gonna reduce the cost of the microinverters or the type of microinverter you are using, uh, and also in the racking and the BOS. If you are not using microinverters, please choose a string inverter with a software to help the shade fix. Okay, that is really, really important because with that type of software, you're gonna have a between 0 and 20% less losses due to shading. Okay, so it's also important if you are doing a string inverter residential project. And last but not least, choose a long-lasting racking that is not gonna give you trouble in the future, and that is fast and easy to install. That it's really important for you because an installer you can install more is gonna cost you less in the same time. Okay, and also very important the certification of that racking that you can be able to uh, certify the customer that with a hurricane or with a atmospherical type of problems, or yeah, you're not gonna be having any problem with the photovoltaic system. Okay, so thank you so much, everyone. If you have any question, please feel free to put it in the chat. If not, please feel free to write directly to us, to me, Carlos Hernandez. This is my phone number and my email, and also to Jimena Dayos, that it's our commercial engineer. This is her phone and her email address also. So yeah, thank you so much for coming, for being here with us in this webinar, and I hope to see you in the next one. If you have any questions, please feel free to put it in the chat, and we're gonna be here to answer them for a few.